Hi everyone, I hope you're doing well today. What we're going to be going over today is we're going to be learning about evaluating logarithms and everything about logarithms and how they started to come about. So let's just jump right into it. So first we're going to talk about what are logarithms. Logarithms actually have an interesting history, and it actually stems from exponential functions. Let me switch over to my pen. So exponential functions, we learned that they have the form that looks like y equals b to the x. The reason that logarithms came about is because there was no way to find the inverse of this. And so we actually learned that the inverse of exponential equations are actually the logs. So when we have the inverse, we're going to get x equals b to the y, and like you don't know anything about how to solve back for y when we're finding the inverse. And so to solve back for y, you use the logarithm, which is going to be y equals log base b of x. So listen to how I say this part. This is log base b of x. Don't write the b here because that would mean something else. And don't say log bx. Don't say something like that. There are a couple other things that we also have. We have the common log, and so when you have log and your base is 10 of x, then all you write is log of x. So the 10's not written, but it's understood that there's a 10 there. So this one was called the common log. Let's see, common log. Let's get rid of this one. Okay, so that one's the common log. And then the other one that we actually need to know about is when you have log base e of x. Now e is a special number, kind of like pi. So we have pi on the calculator, so here's pi. But e we also have. And it gives us this number here. So it's another irrational number, and that's e's has a lot of uses in terms of finance, science, things like that. So that's why we also have one like with the base of e. And when you're talking about it, you actually get the natural log of x. So I know it says ln. Don't say ln. I will throw a piece of chalk at you. But we say this is the text box natural log. So just kind of think of it backwards. ln natural log nl. All right. So those are the things that we need to know about and that come about in terms of logarithms. But let's get into just how to use these. So when we're rewriting these in exponential form, we're going to write this as my base, which is 2, to the 5th equals 32. So that's how you're going to be doing all of these. So you write your base. This is going to be your exponent, and then 32 is going to jump to the other side. So we're going to do that again. So 7 is my base. This becomes my exponent, and that's going to equal 1. And that makes sense. 7 to the 0 power is 1. This one, the base isn't given, but here the base is understood. The base is understood to be 10 because it just says log. So we're going to write 10 to the negative second equals 1 over 100. And this one, again, the base isn't given, but anytime you have natural log, you know that the base is going to be that number e. And then e to the negative first equals 1 over e. And this makes sense because 1 over e, we know from exponent rules, that's just e to the negative first. So we know that that these are equal. You know that 7 to the 0 power is 1. You know that 2 to the 5th power is 32. 10 to the negative second is 1 over 100. So these are all making sense. But let's actually go in the other direction now. Let's rewrite these in log form. So we know that we're going to have log, and we're going to go basically backwards. So the 6, that's still my base. So the 6 is my base, so the 6 is going to go here. Then 1 over 36, that's going to jump into the log, so 1 over 36, and that's going to equal negative 2. So log base 6 of 1 over 36 equals negative 2. So let's do it again. Log, this is going to be my base, so 81. 3 is going to jump inside, so 3, so log base 81 of 3 equals 1/4. Here, same thing, except my base is 10, so I'm not going to write log of 10 because it's understood that log is base 10. So log base 10 of 100, because the 100 is going to jump inside, and the square is going to come over here. So log of 100 equals 2. And now last, we have e, that's my base, and whenever I have a base of e, that's going to be written as natural log. The e here is going to jump inside, so natural log of e equals the exponent part, which jumps outside, 1. So natural log of e is equal to 1. So that's how we can rewrite these all in log form. So we've done, in our last example, we did rewriting them in exponential form, and now rewriting them in log form. Here, I want you to try these two problems out on your own. Okay, so we've rewritten these in exponential and log form. So check to see that your answers are correct. Common mistakes are to still leave, to not swap them. To like write log of 1/2 of negative 6 equals 64. But you do have to switch those numbers out. So if you're looking at your calculator, we actually have these two buttons that we've been talking about. So I showed you the number e earlier, but you also have log, and so you can type in log on your calculator. And again, this is always going to be assumed to be base 10. And then if you hit second, oh wait, no, not second. If you just hit right here, natural log, it gives you natural log. And again, the base for natural log is going to be e. So if I type in like second natural log of e to the first, which is a problem we had earlier, we got 1. Like, let's see, we did have that problem earlier, right? Yes, natural log of e and then to the first power, and we got it to be equal to 1. So we're showing how you can see those things on your calculator as well. However, none of that's really useful until you can actually evaluate logarithms. And so evaluating logarithms is actually going to be 3 quick steps. So let me actually get those steps written out here. So those are going to be the 3 steps to how we do this. And so that's why we practiced writing the log in exponential form just a moment ago. So here we're going to write this in exponential form, and we're going to just leave a placeholder because we're just going to say it's equal to x. Okay, and so when we do this, I have my log base 7. So my base is 7, and it's going to be equal to x equals 343. Okay. So I rewrote it in exponential form, but I don't have a common base on both sides. So I can rewrite 343 as 7 to the 3rd, because 7 to the 3rd is 343. So I can rewrite that. So I'm going to go ahead and do that. So 7 to the x equals 7 to the 3rd. And now since I have the same base on both sides, I can set my exponents equal to each other. So x equals 3. That's it. So the log of 7 to 304, or log base 7 to 343 is equal to 3. All right, moving on. When we're writing our next one in exponential form, we have to remember that my base is 10. It's not written, but my base is 10. So when I write this out, and this is going to be equal to x, we're going to have to write 10. I'm sorry, that's not 10. Okay, so 10 to the x equals 0.001. Well, how can I write 0.001 with a base of 10? So 10 to the x equals, when I write this out with the base of 10, I know I can write this out as 10 to the negative third, and that's 0.001. So I can write this 0.001 as 10 to the negative third. And then all I do is set x equal to negative 3. And then there's no solving here, so log base 10 of 0.001 equals negative 3. We can actually check that on the calculator because the calculator has log base 10. So 0.001, that is negative 3. Our next one here, we have log of 1/3 equals to x. So we want to solve for x. So we're going to see 1/3 to the x equals 729. So I don't want to mess with the 1/3, so I'm going to switch this over and I'm going to have 3 to the negative x. And I can do that because the reciprocal, all that does is switch the exponent to negative. And now 729, that can be rewritten as 3 to the 6th power. So now all I have to do is negative x equal to 6, divide by negative 1 on both sides, and I'm going to get x equals negative 6. Alright, moving on to these same kind of problems but just different properties. I think these problems are actually pretty cool, but we're going to be setting them up the exact same way. So starting out with log base 16 of 8, we want to see what that is equal to. And so we're going to say 16 to the x equals 8. Alright, but here we notice a common mistake would just be to multiply this one by 2. And that's not really going to do anything, or divide this one by 2. And those are not algebraic steps that we can do. What we actually have to do is find that common base. So those rules, I'm actually going to bring those rules back. So here we go. So I just want those rules because we need a common base on both sides of the equation. So in order to find that common base for 16 to the x, I do know that 16 and 8 are both multiples of 2. So I can write 2 here, and then 2 to the 4th power. That'll make 16. And all I have to do is still multiply into that x. And 8 is 2 to the 3rd power. So now they do have that same base. And so all I have to do here is go 4x equals 3. And then divide by 4 on both sides. And x would be equal to 3 over 4. Let's go on to this problem. Natural log 1 over e to the 3rd. Again, natural log is not written, but we want to see what this is. So natural log is going to be a base of e. And e to what power? So e to x is going to be equal to 1 over e to the 3rd. Well, what I can do here is I can write this as the reciprocal. So e to the x, 1 over e to the 3rd, I can write that as e to the negative 3rd. So now I have that base of e, the exact same, and all I have to say is x equals negative 3. And in this case, don't have to solve for any variable, it's already solved for. In this last example, let's check it out. I'm going to have 8, no, that's a e, not an 8. Okay, so 8 to what power is equal to 128? So what I can notice here is that 128, let's see, 2 to the, what was it, 6? Nope, 2 to the 7th is 128. And 8 is also a multiple of 2. So all I have to do is write this one as 2 to the 7th and write this one over here as 2 to the 3x. So 2 to the third is that 8. So we're making it the exact same thing. We're not really changing anything here. And now I would write 3x equals 7. Divide by 3 on both sides. And x would equal 7/3. Okay. So those are going to be our examples. And let's go ahead and check out these last 3 problems. Get these last 3 problems and the answers will be up in just a moment. Okay. 1/2 x equals 32. 2 negative x equals 32. 2 to the negative x equals 2 to the 5th. Negative x equals 5 divided by negative. Alright, so now all the answers are up here. Make sure you check your answers and make sure you're going through it step by step, really showing everything that's happening. But that's going to be the last of this lesson. Really, if you have any questions, make sure you contact me, let me know. My name is Mr. Hernandez, and I'm always here to help.